Cannizaro reaction is an important organic reaction for aldehydes. So one thing first and foremost we need to remember is aldehyde undergo Cannizaro reaction. Cannizaro reaction is only shown by those aldehyde which do not contain alpha hydrogen. What are the examples of aldehyde which do not contain alpha hydrogen? It is formaldehyde. The formula for formaldehyde is HC double bond OH. This is your functional group alpha. There is no alpha carbon attached to it on both the sides, so there is no chance of alpha hydrogen. When we talked about the acidity of alpha hydrogen for carbonyl group, we talked that alpha hydrogens, we discussed that alpha hydrogen are those hydrogen which are directly attached to alpha carbon. So when there is no alpha carbon present, so there is no alpha hydrogen. So there is no chance of alpha hydrogen present. So for a hydrogen to be termed as alpha, there has to be a alpha carbon. So no alpha carbon, so no alpha hydrogen also. So this is what you have to remember first. So Cannizaro reactions are possible in those aldehyde which do not contain alpha hydrogen. Example of those aldehyde which contain alpha hydrogen is CH3 C double bond O H. Functional group carbon, this is the alpha carbon. So these hydrogens are 3 alpha hydrogens. So this is how you are going to differentiate between what is alpha hydrogen and which groups contain alpha hydrogen. So simple thing in the beginning itself we are talking about is that Cannizaro reactions are possible in aldehyde which do not contain alpha hydrogen. So one thing is formaldehyde, the other example is benzaldehyde. Benzaldehyde has a benzene attached to C double bond OH. So this is your functional group, no alpha carbon present, so no alpha hydrogens. We can also write this particular benzene structure as C6H5, C double bond OH. So Cannizaro reaction is a redox reaction. Cannizaro reaction is called as a redox reaction because in that particular reaction we can see reduction as well as oxidation happening simultaneously. So those reaction which shows reduction and oxidation simultaneously are redox reactions. Next thing which is very important for us to talk about is what is happening in Cannizaro reaction. Cannizaro reaction occurs between two aldehydes which do not contain alpha hydrogen. So I'm writing here two aldehydes which do not contain alpha hydrogen. I'm writing cross for do not here. In the presence of a base, it can be NaOH and H3O plus hydronium ion. It gives us an alcohol and carboxylic acid. Specifically, I'll write down acid here. You know very well aldehyde is R C double bond OH in presence of NaOH and H3O plus gives us RCOHH plus RC double bond OH. This is supposed to be reduced form of aldehyde. This is supposed to be oxidized form of aldehyde. How do you say that is when this and this structure is compared, and you can see that this has hydrogens as 1 and this will be having hydrogen as 2. This particular oxygen uh, group has 1 oxygen and this has 2 oxygen. So in that case we can differentiate that when you compare this and this, it is supposed to be reduced. When you compare this and this, it is supposed to be oxidized. This is what you have to remember. So Cannizaro reactions is a redox reaction where one of the aldehyde is oxidized to acid, one of the aldehyde is reduced to alcohol. This is the simple thing what we are going to remember in the beginning before you proceed with the mechanism and all. Now general reactions for Cannizaro, we are going to first see formaldehyde can be represented as HC double bond OH. You're going to use two formaldehydes here. I'm writing two in the presence of a base that is NaOH H3O plus. This will now change into alcohol HCOH H. We check the valency of carbon here. It is 1, 2 and 3. So it will have one more hydrogen here. So now this is proper alcohol. It is called as CH3OH. That is methanol. And for acid it is HC double bond OH. It is called as formic acid. So when you're using two formaldehyde, when they are subjected to a basic medium and in the presence of hydronium ion, it is going to give us methanol, methanol, this is alcohol, and formic acid is an acid. So this is oxidized, this is reduced. If you are having difficulty in understanding, you can write down two formaldehyde. Once again, HC double bond OH plus one more formaldehyde. So these two formaldehydes will combine to give us a product that is methanol and formic acid. Now next thing what we are going to see is with respect to benzaldehyde. This is benzaldehyde. You're going to take two benzaldehydes, same medium NaOH H3O plus. This will give us phenyl ring as it is COH H and H. So this is benzyl alcohol plus phenyl ring as it is C double bond OH. This is benzoic acid. So one thing you can generalize here for remembering the reaction easily, we have taken two formaldehydes here and two benzaldehydes here, same medium. What is the thing is this is not changing. So this group is remaining the same. So this here also remains the same, here also it remains the same. Only thing is the C double bond O here for one of the aldehyde will change to OH and it will add one more hydrogen here. This is the case here and here also. And for acid part, this part remains same. Only thing is we have one more extra oxygen added here on both the sides. So where it is supposed to get oxidized, we are adding oxygen. Where it is supposed to get reduced, we are adding hydrogen. That is how you can generalize for remembering. So to generalize it, we can write down instead of this hydrogen and benzene, I'm going to write down R, which can either be hydrogen or this particular phenyl ring. So instead of H and R, I'm writing R, C double bond OH. These are taken twice in the presence of NaOH and H3O plus. First it gives us an alcohol, that is R C. Instead of this particular group we are going to change it to OH. Hydrogen is already here, one more hydrogen is added, it is alcohol, and the other one that is will be changed to R C double bond O will be as it is. Here we are going to add O instead of only H. This is supposed to be your acid. This is your general reaction for Cannizaro reaction. Now to understand the details of the reaction, we will go to the mechanism of Cannizaro reaction. In the mechanism of Cannizaro reaction, we are going to use at a time one aldehyde. So the first step we are going to use here is in step 1 R C double bond OH in the presence of a basic medium. From NaOH we got this OH minus, which will act as a nucleophile because it has negative charge. So this particular nucleophile will come and attack partially positive carbon. So this will come and attack partially positive carbon so that we get this intermediate, that is R oxygen has negative charge. Already hydrogen is here. It will be attacked by OH. OH can be represented as O bond H. Now once this is done, the other thing which will happen here is the intermediate will lose proton in the presence of a basic medium. So this particular hydrogen will move here in the form of proton That means this bond will shift on this particular oxygen. So this results in formation of an unstable dianion, that is carbon already was having oxygen with negative charge. Now it will have one more oxygen with negative charge followed by R and H. So this is dianion. So the first step of Cannizaro reaction begins with, we are taking only one aldehyde at a time. So this particular aldehyde reacts with a nucleophile, that is OH minus, so that this nucleophile comes and attack carbon having partially positive charge, and we get this particular intermediate where oxygen will develop a negative charge, and this is OH, followed by removal of H as proton, that is called as deprotonation, and this results in transfer of this bond towards oxygen. Therefore we have one more negative charge or anion on oxygen, that is called as dianion, and as this hydrogen is shifting towards OH, we can write minus H2, whatever is removed in this particular step. This is the first step of this particular mechanism of Cannizaro reaction. The second step will be the dianion, which we are going to represent first here as O with negative, O with negative, R and H, is going to react with another carbonyl group, that is R C double bond OH, partially negative, partially positive, as always. The second step begins with the release or transfer of hydride ion. Transfer of hydride ion. Hydride ion is opposite of proton. Proton is having positive charge. Hydride ion has negative charge. Negative charge is due to this hydrogen carrying that bond, the bond attached to it. Proton do not have electron attached to it or bond attached to it, but hydride ion has electron or bond attached to it. So from the unstable dianion, this particular hydrogen will go and attack this carbon in H minus form. That means the bond is carried by this particular hydrogen. So now when this is shifting here, carbon will get positive charge because it is losing this bond. So to stabilize it, this negative charge, which is having two electrons, will shift here, so that the positive charge on the carbon is stabilized. So in that scenario, we are going to get R, this particular R attached to C. Now O minus is changing to double bond O. Already this O has a negative charge, so O with a negative charge. This is called as carboxylate ion. We have done about this. What happens to this is R is as it is, R, C, O with a negative charge. H is already there, and this H minus comes here, so I'm writing here H. This is called as alkoxide ion. Or directly alkoxide. Alkyl group, that is RCH with O minus, is called as alkoxide ion. So what happens in the second step is the unstable dianion transfers the hydride ion, which attacks to the carbonyl carbon of another aldehyde. and this results in the formation of a carboxylate ion and alkoxide ion. The third step is very important. The alkoxide ion reacts with water. We'll write first alkoxide ion from the structure we have written. RCO minus with 2 electrons, hydrogen, hydrogen, reacts with the water molecule formed in the first step, that is HOH. We can write water as like this. So here hydrogen will shift towards oxygen having negative charge in proton form. In that scenario we are going to get RCOH, H, H. This is your alcohol, and this will shift here, so oxygen will have negative charge attached to hydrogen, hydroxide ion. The continuation of your third step is at the same time the formed carboxylate ion, that is R C double bond O negative charge, reacts with hydronium ion, that is HOH and H with oxygen having positive charge. So what happens here is one of the hydrogen will shift towards this oxygen having negative charge. This will shift toward oxygen having positive charge, and it will neutralize to water. So we are going to get carboxylic acid, that is RC double bond OH plus OH H with no positive charge on oxygen. So we are getting H2O as your byproduct. So this is how you get your carboxylic acid. Very simple reaction. It seems to be very tough, but it has to be simplified for our understanding. That the first step is nothing, that instead of using two aldehyde at a time, we have begun with one of the aldehyde and react with a nucleophile, that is OH minus, and it results in the formation of intermediate followed by removal of hydrogen here as proton to form dianion, which is unstable. The dianion reacts with another mole of aldehyde, which results in removal of hydrogen as H minus, that is hydride shift or hydride transfer, that result in the formation of carboxylate ion and alkoxide ion. This two things followed by here addition of proton from water and hydronium ion here results in the formation of alcohol and carboxylic acid. So if you practice this mechanism, it is very simple. Now in the syllabus they may ask you write down about only Cannizaro reaction. So what you need to do is, instead of R you can change this R to H. If you change this R to H here and everywhere, then you are going to get finally I have not changed everywhere, I am just telling you this was a general reaction. When you change the R here in the normal Cannizaro reaction, then you are going to get alcohol, that is methyl alcohol. This one will be a methyl alcohol CH3OH, and this one will be formic acid. In case of cross Cannizaro reaction, we can use one as benzaldehyde, the other one as crossed or mixed, as we have seen in aldol condensation. That we are using different aldehyde, that is for benzaldehyde and acetaldehyde. Here we are going to use benzaldehyde and formaldehyde in cross Cannizaro reaction. So what you are going to write here is C double bond OH reacts with C double bond O HNH in the presence of NaOH 30%, they have specified in some notes, H3O plus. We are going to get COH HH, that is benzyl alcohol plus HC double bond OOH formic acid. That means that we are going to use different type of aldehyde which do not contain alpha hydrogen. This one is benzaldehyde, this one is formaldehyde, this is your benzyl alcohol product, and this is formic acid. Mechanism will also remain same. Only thing is, in the first step we are going to use, we can either use this benzaldehyde or formaldehyde, but with the help of general mechanism which we have seen here, that the reaction should begin, the dianion which is forming here is resulting in the formation of carboxylate ion. So carboxylate ion, that means we need to begin our reaction with formaldehyde, that is H C double bond OH, OH minus act as a nucleophile. This shifts here because of partially negative charge on oxygen, partially positive here. This results in the formation of carbon having negative charge. Here you will have OH, or for a better understanding, as we have represented before, we'll write down carbon having O minus. Here this was the H already, this was also the hydrogen which we had, then OH, followed by, in the presence of basic medium, hydrogen shifts here as proton. So this is coming here, so result in the formation of CO minus, O minus, hydrogen dianion. This is followed by the second step in cross Cannizaro. In the notes it has not given, but I'm just explaining you what we have to do if they ask in the exam. In the second step, the dianion which is formed, there is CO minus, O minus, H and H reacts with benzaldehyde, another aldehyde which do not contain alpha hydrogen. Hydrogen is removed in this shifts here. Oxygen has partially negative, carbon partially positive. Hydrogen shifts here as H minus. This will shift here. To neutralizes this bond has to shift here. This results in the formation of H C double bond O minus plus benzene CO minus H and H. This is your formate ion. This is your benzyl oxide ion. The third step begins with benzyl oxide, which we have benzene here instead of R, benzene ring, CO minus H and H reacts with water. Hydrogen comes towards O minus as proton. This bond shifts on oxygen. We get our alcohol OH, H and H plus OH minus, followed by this is your benzyl alcohol. And we have H, C double bond O, O minus reacts with OH, H3O plus, proton shifts here, this shifts here, so that we get H, C double bond O, and O minus will change to OH plus H2O. This is formic acid. This is how we are going to represent the cross Cannizaro reaction. This is very simple. Just understand the basic concept what we have studied, practice it, and just let me know if you have got any doubts. Thank you.